Hi, this is Aaron with iBoard Repair, and today I'll be demonstrating the full process of an iPhone 16 Pro Max CPU swap. And I have the phone here, and I've already taken it apart. And it's largely undamaged. It has no cracks. I've removed the motherboard, and this phone was reported to have stopped working randomly overnight. It went to a repair shop, and it now has shorts underneath the CPU. So in this video, I'll show you how I deal with this. The CPU swap procedure on the iPhone 16 series is harder than any previous models because the underfill is much harder and tougher than any previous models. Let's get started right away with the process. Here's the motherboard. The layers have already been split by a previous technician. And I don't know what the original problem exactly was on this motherboard. It was just reported by the customer to have stopped working. But the previous tech removed the PMIC, and the PMIC is also quite difficult to remove on this series because, again, of how hard the underfill is, and it doesn't like to release any of these components. Even if you use quite a lot of force, it doesn't like to come off. And it looks like the previous tech probably used too much heat, as evidenced by these solder balls on these capacitors next to the CPU. And while they are working on the PMIC, they likely damaged the ACE charging chip here, because we have solder balls popping out of here as well. And I see a lot of these CPU line capacitors, they've been removed, so it seems that the technician was trying to hunt down some short. But this short, it's surely underneath the CPU at this point. I don't even have to really know which lines these are, but if I measure them, we are getting full shorts on both sides of the pads. All the signs here point me towards an overheated CPU. And when the CPU's been overheated, especially on this series, sometimes it likes to damage the underside of the CPU. It will like damage the surface layer so it no longer has like any type of protective film on it, and then the entire surface gets tinned by the solder when you're running your iron over it. So hopefully that's not the case. I'll have to pull the CPU up and take a close look at it. I wish I knew what the tech was trying to solve, because I don't know what the original issue was and the reason why he was removing this PMIC. I can't really rely on any reports. I kind of just have to work with the evidence that's in front of me, and all I'm seeing here is a lot of signs of a motherboard that's been overheated. And my very first step will be to remove the underfill along the outside of the CPU, and then get the CPU up and we can examine it. This is actually the third CPU swap video I've made for the 16 series, the 16 Pro or Pro Max. But my very first one, I had terrible audio, and I don't think it's worth trying to use it. And my second one, it went well, but I ran into difficulties that I didn't need to. It was made more complicated than it had to be, and it just makes for a less than straightforward video. So that's why I'm giving this a third shot here and just trying to get a clean CPU swap where I don't have to do too much editing, and we can just view the process. The iPhone 16 Pro and Pro Max, in general, it's a more difficult motherboard to work on, and I'm seeing it damaged a lot more by technicians, because it changed up a little. It changed up a few things. For one, there was only very few models that had the CPU and the NAND on the bottom board in regards to the orientation that it's placed on the heating platform and within the phone. Like the base 14 and the base 15 iPhone series, they had the CPU and NAND on the bottom board, but the Pro and Pro Max, which most people work on, it was set up normally with the CPU on the top board. And when you're splitting it using a heating platform, it helps to have the CPU and NAND on the top board, because the heating platform can do a lot of the work. And especially if you're just worried about data recovery, it doesn't really matter too much if the RF board is overheated. If you need to repair the phone, then you just need to have pretty good heat control. But aside from that, it's just this underfill, I think. The underfill on the 16 series is just really hard to work with. It both doesn't like to release the chip as well as seems to kind of like damage the chip earlier than the heat than the equivalent heat on previous models would. I've seen a lot of videos lately of technicians, specifically Chinese technicians mainly. They're completely cutting away this section of the interposer in order to get underneath the CPU. Um, I've been able to do it just by removing the rose IC and getting underneath in this spot here. Sometimes I'll remove a couple of these other capacitors, but sometimes I can get in right here. I've kind of had to change the pressure and angle of my insertion tool. I have to press down into the motherboard a lot more in order to not damage the chip because I have to apply kind of more pressure than I like to because again the underfill just really doesn't like to release, and that's clear evidence by the last technician who worked on here. It looks like they struggled quite a bit to get this PMIC off. So I imagine I will also probably struggle to get the CPU off. And I hope the undersurface is not damaged, neither by me applying too much heat or by the previous technician overheating the board prior to getting to me. Rose IC is not needed for data recovery and normal boot up, but if you update the phone, it won't pass the update unless that chip is on the board. And then you'll be stuck in recovery mode after that until it's returned to the board. Not too bad. I did have to leave that spot, which is fine. I don't care about the native board. It can be messed up. I'm pretty happy to see that none of the edges of the CPU were damaged, which is a little bit more common on this series. A lot more common on this series in comparison to other series at least. But this looks pretty easy to clean up. Let's get it reballed and ready to go onto the donor board. And I'll use my Keon Lee 007 hook tool in order to clean the rest of this underfill off of the bottom of the CPU surface. More importantly than using any specific tool when you're cleaning the underside of a CPU is using a tool that you're extremely familiar with how it feels in your hand and how it feels against the surface that you're working with, whether that's the board or the CPU, because you have to be extremely delicate when you're working with CPUs or you can damage them. I'm trying to see if the laminate is damaged. The laminate will like sometimes come off, peel off of the board, and usually will be stuck actually on the native motherboard where it was sitting. You can see like a surface layer of it, and I don't see any of that on this motherboard. So that's really good to see. That means all of the laminate is still on the CPU, I'm assuming, because of how much heat the CPU requires. Sometimes you'll see a couple of little sections that have been taken off. And actually that happened in my last CPU swap video that I said I never released, but I have footage for. Let me just show you a little clip of that. I had this one titled 16 Pro Max Severely Broken CPU Swap, and you can see this was filmed in January of 2026. I have another one titled 16 Pro Max CPU Swap parentheses bad audio that was filmed in July of 25, so an entire year ago. And it looks like both of these videos had a damaged undersurface. And yeah, I remember this was one of my very first ones, and I just used that one access point to pry the CPU up. And not only did I sever the ground line that goes along the outside, but I had actually also shorted two of the RAM power rails. I think it was the OV5 and the 1V1 line, so I had to dig those out, and that was quite a pain. You can see I just kind of completely dug out that layer here. And this video was actually pretty good, but I lost audio almost for the, no, I didn't even lose audio. I had like a wah 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 audio. I just had terrible audio quality. So I was never able to actually release this one without some heavy editing, which I didn't really have time for. But we can see here that it did work, and this was an entire year ago. And then I had the footage for this CPU swap, and I like this one because it was quite heavily damaged. It would have been a pretty good video, but it got way unnecessarily complicated. Everything went well enough. I actually did, again, damage the undersurface of the CPU. Let's see if I can find it. Just a little bit. You'll see I had some tinned ground here because the laminate again came up. And I had to dig out any individual shorts. I had to mask this off, and I had to get all of the pads fixed, which I did manage to do. And again, you can see I had actually damaged the side in that same spot, but this time I didn't short the lines. I had just I severed that ground that goes along the outside. I'll clean up all of this factory solder now. I'll just put some leaded solder onto my iron here, and I'll run it over these pads. And this will, at the same time, suck up the solder that's there, as well as mix it with the leaded solder to make it easier to work with. And I usually do it, as you can see, without really letting my iron touch the CPU. I let the blob of solder touch the CPU, so there's no chance that I damage the surface of the CPU with my iron. And then if I have pads that didn't want to take solder, I can be very gentle with them and touch them with the iron directly to tend them. That looks pretty good. I'll just clean off the flux now, and then we can reball the chip. So we can see one tiny little dent in the ground line that runs along the outside of the CPU, and one tiny little speck of delamination. I didn't notice that before, but it doesn't matter, but it's interesting to point out. I've got my CPU in its magnetic stencil holder. I like to dry out my solder paste just a little bit before I use it. And I do that with my hot air, and then I'll pat it dry a bit. And I've been using this ceramic like spudger to spread the solder paste, but it feels quite different, so I kind of have to get used to it. But I've been liking it so far. And this is because it's a strong magnetic stencil, so the ceramic won't pull towards the stencil like a metal tool would. With this tool, I have to use the flat surface a lot more deliberately, whereas my other scraping tool, I'd kind of use like the tip or the edge a bit more. It's just funny to notice the difference in the littlest differences in how the different tools feel. This looks pretty good, so I'll apply my hot air and melt the solder into solder balls. My solder was a bit too wet or something. I don't like how some of the holes are filling. That's why I'm kind of moving my heat around a lot. Whenever there's a problem with your solder ball, it's almost never on the corner that you're working on. So I'll do one corner at a time. You also don't really want the solder to melt within the stencil like this at the very corner. You want the chip to heat up enough that the solder will suck to the chip as well, rather than just forming a ball and sitting on top. Which if you spread your heat too much, it has the potential to do that. So you do have to like focus on one area. And this is just how I do it. A lot of other technicians do it very differently. In fact, I feel like I'm the only one that kind of heats like this. A lot of other technicians just go all the way through and have no problem with that. I just found it's a little bit more reliable for me to do it this way. And there we go. That looks like a pretty near perfect reball. I'm sure it's going to work great. And I'll give it one more reflow with some flux to make sure all the solder balls are connected nicely. I pointed out one tiny damaged area and I didn't mask it off. and it has become tinned a little bit. So I will have to check out these solder balls that are right next to it and make sure that nothing that isn't supposed to be ground is measuring ground. I should have taken the 1 minute it would have taken to mask that off. I just didn't really think it'd be a problem. I still don't. I think we're probably fine. I think one of those is ground and the other one isn't. So as long as the top one isn't short, I think I'm probably fine. But I'll double check. I just checked, and this one is not supposed to be ground, and it's not reading ground. This one is ground, so it's okay that's reading ground, so that's fine. I also double checked the the line that we measured short on the motherboard to make sure it wasn't short on the CPU itself. I measured that, where was it? It's this line. And I'm not 100% sure that all of the lines are necessarily connected on the CPU side, so I can't really say for sure that the CPU is not short, but I measured at this pad here, and it gave me like a 0.7 in diode mode, which I don't know if it's normal or not. The 0.32 that we see here is irrelevant. It's not the reading that we would see on the CPU. So CPU looks good. Let's go ahead and remove and reball NAND now. Just like the CPU, I'll start by removing the underfill along the outside of the chip. I'll remove the chip now. Just like with the CPU, it's really hard to get the chip to release. But you can see when I put pressure here, I'm putting pressure down into the board to avoid damaging the chip. And this is a really good tool that I use because it just bends perfectly. It has the perfect flexion in it to not really allow me to like pull very hard, to not have very much force. It's kind of a perfect bend. I've used this tool for years now, and if I ever have to replace it, I don't know what I would use. Some tools wear down pretty quick, like my iCrescents I have to replace every once in a while. This one is kind of not sharp enough anymore. This tool, it's been many years since I've been using the exact same one. This tool, like my little metal shim tool here, it is my oldest and most widely used tool of everything that I have here. It has always retained shape. The flexion has always been perfect. It doesn't bend despite being used for probably 10 years now. And anytime I've ever tried to replace this, every single other one I've ever found has not been anywhere close to whatever this one was. So I have some tools that I really love here that I've gathered over the years, just very simple hand tools. That was probably actually closer to 15 years ago that that tool was purchased. That little metal pry tool I still use to this day to open every single phone that I open. Every single phone that comes in here, that tool is used for. I wouldn't sell that tool for $500. I'll go ahead and remove the underfill on the bottom side of the NAND chip now, and we can get it ready to take a reball. And I should have a donor board that's it's not fully prepared, but it's been used before. So it's the underfill has been removed already. It was prepped at one point, and then it's been used. So I'll just have to remove the leftover solder that's on it now, but it should be quick work to prepare the donor board for another use. With this crescent tool that I've been using it, I don't know, probably like 2 years now. I used my tools for a while before I have to replace them, which makes replacement quite painful. But even after, I won't be using this for scraping at the side of the chips, for scraping the underfill of the side of the chips. This tool is quite perfect for scraping the underfill off of the chips when you turn it around, and I'll be continuing to use it for that for a very long time. It doesn't scratch the surface of the chips. And I mentioned earlier, you just really, more importantly than like having any specific tool, it's just really knowing how to use whatever tool that you're using. There's a lot of nuance to hand micro soldering. So the smallest little things, they all add up and matter a lot. I'll spread the solder paste onto the stencil. And I use my hot air to melt the solder into solder balls and reball this NAND memory chip. And NAND also looks great. I still need to grab the EEPROM from the original motherboard, but first let's go ahead and prepare the donor board. So this one is actually a 16 Pro, but the motherboard is completely usable still. I just have to change one single resistor. And it's probably this one because it looks like I've already changed that one once, but I'll double check. I'll go ahead and remove I'll go ahead and remove the donor board CPU now. It should come off really easy. As I mentioned, there's already no underfill underneath this chip, and this chip has been reballed one time already. So it also has leaded solder, which melts easier than the factory solder that comes on the board. And I can already see these grayed out pads on this donor motherboard, meaning that this CPU was one of those cases where I had to fix the pads underneath them. It's probably actually one of those videos that I showed earlier. And that will make cleanup really easy. Because there's a lot of solder on the motherboard still, I'll just run my iron over it first to pick up as much as it can. And after that, I'll go in with a solder wick to make them completely flat. And I recently found out I'm one of the only ones that also make these pads completely flat. I've been doing it that way for a long time, but I think like most of the courses, they don't really teach you to wick these pads. They just teach you to run solder over them. Which if that works for you, that's fine, but I already have ways that I know work really well for me, so I'll continue to use them. CPU area looks good. Let's change the board ID resistor so it knows it's a, what are we moving? We're moving from a 16 Pro to a 16 Pro Max. We can take a measurement on the resistor that's here now and see it's a 1 ohm resistor. And let's measure this one. This one is 1K ohms. So yeah, I'll go ahead and swap that out really quickly. So I just took the resistor off of the donor board, and now I'll harvest this resistor from the original board. Okay, that looks great. Before I flatten the NAND pads, I think I'll just go ahead and swap out the logic EEPROM now. And that's just because I have my small nozzle on my hot air. And I like to remove this with the small. And now I'll pull the EEPROM off of the native board. And we'll transplant it over onto the donor board. Okay, that looks perfectly fine. The EEPROM is directly opposite the PMIC, so I will have to turn this over and make sure that wasn't overheated, but it felt like it went fine. So now I'll go ahead and I'll flatten these NAND pads, and then this board should be ready to take the CPU and the NAND. It should be finished pretty soon. I have a couple of really old solder balls around the PMIC, probably from the last time I changed that EEPROM, but it's already proved to be working. But no matter what, before you do your final CPU swap and NAND swap, it's worth it to test your board and make sure it's behaving normally before you put anything else down. And it gets a lot more confusing because right now it should have a specific behavior. So I'll clean this up just a bit more and I'll put it into my testing jig and test the amperage draw and make sure it looks normal. Here's my testing jig. And this is the RF board. It's a known good board that I use when I'm pulling data. I'll put the CPU board on the bottom here. The part that connects or works as the interposer. And now I can do some normal amperage draw testing. So I'll take my DC power supply probes and I'll touch them to the battery connector here. with battery voltage. And I'll short the power button line to act as a button press. 0.00 or 0.05 amps is probably normal. I normally actually see 0.01 or 0.02, but I also normally test before I put the EEPROM down. And the EEPROM is a very early part of the boot up sequence, so it's probably drawing a little bit more because that's on the board. So to me, that passes, and I think it's good to go. So I'll put NAND down first. I'll preheat the board just a little bit with my hot air. And I just do this just so when I put down my flux, it melts instantly. I don't like to have cold flux on the board when I put the chip down, because it will make the chip move out of place when I apply more hot air. But if it's pre-melted, it works as like an adhesive almost. It's a bit sticky. The only good thing about having absolutely zero space to work with is that alignment becomes extremely easy because it only fits in one spot. It's almost impossible to put this on here and have it attach in the wrong way. That looks pretty good. I'll turn it over and we can get the CPU down next. And I'll do the same thing here. I'll preheat the board just a little bit. Put a little bit of flux down. There's the CPU. This doesn't look too bad. Let's go ahead and get it fused to the board. Should be good. I didn't really see it move at all, but the amount of time that took should be sufficient. We can give this one final cleanup, and I'm pretty confident it should be working. We should also test that line that was initially short to make sure it's not short any longer. And I have my NFC chip right here on the top board, or on the CPU board. And I'll change it if the board boots to swipe up to recover mode. And if it doesn't, then I'll just go ahead and skip that part. Swipe up to recover has in the past been mostly safe, but I'm a little bit unsure if that's still the case 100% of the time with some of the things I've seen. So if I can avoid going through the swipe up to recover validation, then I'll avoid it. First thing I will do again is put the board into my testing jig, and we can just test the current consumption. I've got the board in the jig, so I'll take my DC power supply probes, touch them to the battery connector, and tell this phone to turn on again by shorting the power button. And let's see what this looks like. Looks pretty normal so far. I've got the parts connected. Let's prompt it to boot by shorting the power button. We have an Apple logo. Here we go. And it is booting to swipe up to recover. And that's due to the mismatched NFC chip. That doesn't happen every time, so I don't always transfer it by default. And you can probably go through that screen and be okay. But there is a couple reported cases where it's unclear if that's that like verification process has caused a sort of data corruption. So I try to avoid it when I can. So I'll just go ahead and I will move over the NFC chip, but that is quite good enough for me. I'm sure this phone is working and this is a successful data recovery by performing a full CPU NAND and EEPROM swap on an iPhone 16 Pro Max or the A18 Pro processor. I'll move this chip over and I'll pull the data and count this as a success. Thanks for watching and I'll see you next time.